This section is about graphing linear inequalities. And as you can see in the definition, a linear inequality resembles a linear equation, but with an inequality symbol instead of an equal symbol. For example, y greater than negative 3x minus 2 is linear inequality, and y equals 3x minus 2 is the related linear equation. The graph at the right is the inequality y is greater than negative 3x minus 2 as shown at the right as a shaded region. Every point in the shaded region satisfies the inequality. The graph of y equals negative 3x minus 2 is the boundary of the region. It is drawn as a dashed line to show that the points on the line do not satisfy the inequality. The symbol was less than or equal to or greater than or equal to the points of the boundary would be satisfy the inequality, so the boundary would be drawn as a solid line. I'm going to explain some of that here in just a second. But basically what it means is that in a linear inequality, one side of the boundary line that is formed by just graphing your typical y equals mx plus b linear equation is going to be shaded. The shaded side contains all the points that makes it a true sentence. So look down to example number 1. This is the process. It says graph an inequality, graph x plus 4y is greater than 2. We're first going to graph the boundary line of the graph of x plus 4y equals 2. So basically, we're just going to go ahead and solve that for y. So let me rewrite that. So it's x plus 4y is greater than 2. And to solve this for y, we could subtract x from both sides. That would give me 4y is greater than negative x plus 2. So I can't actually put those together because they're unlike terms. And I'm going to put the negative x part first because, again, if we're trying to get it to slope-intercept form, that's going to be closer to get it into that y equals mx plus b that we're looking for. And then we finish it up by dividing by 4. So y is going to be greater than, now remember there is a negative 1 in front of that x, so when we take negative 1x divided by 4, we get negative 1/4 x. And when we take 2 divided by 4, 2 divided by 4 simplifies to 1/2. So it's y is greater than negative 1/4 x plus 1/2. So then we go to our graph, and we graph that by placing a point on the y-axis at 1/2 for our y-intercept. So that's about right there. And then our slope is negative 1/4. So from that point, we'll go down 1 and over 4. So down 1 over 1, 2, 3, 4 places it right there. And we can do that as many times as you want. Down 1 over 1, 2, 3, 4. There's the next point about right there. And then we connect those with a straight line. And there you go. Put a couple of arrows on each end of that to show it keeps going forever. Okay, now, what type of straight line should we really connect that with? Because notice that back here in the original problem that it was just a less than or greater than symbol. It was not equal to. So here at the top, it talked about using a dashed line. We use a dashed line when it is a less than or greater than symbol without being equal to. So use a dashed line. If it's greater than or equal to, less than or equal to, we're going to use a solid line. So this one was just greater than, so we're going to use a dashed line. So you can draw a dashed line on your graph. What I'm going to do is I'm going to draw my solid line there, and then I'm going to take the eraser and I'm going to kind of mark out some spots here. Well, actually, it's not going to let me, so let's try this again. I'm going to have to graph it the old-fashioned way by just doing a dashed line. So just like this. There we go. So there's my dashed line. Okay, now one side or the other contains all the points that works. That means it's going to be the shaded side. So to figure out which side that is, we are going to do a test point. We're going to pick a point that is clearly not on the line, and we're going to plug that into the original problem and see if it makes a true sentence. Now, a point that's clearly not on the line, and what a great test point will be, is 0, 0. So 0, 0 is located right here. That's the origin. So I'm going to go back to the original problem. I'm going to replace the x with 0 and then replace the y with 0 and see if this makes a true sentence or not. So is 0 plus 4 times 0 greater than 2? Is that true or not? No, because that would give me 0 plus 0, and that is not greater than 2. That is a no. So that means the side that contains 0, 0 is not a part of the solution set. So the side that is part of the solution set must be the opposite of that, or in this case, the opposite of the 0, 0 side is above the boundary line. So I'm going to shade above the boundary line. All the way across the graph, all the way down to the graph. Any point that's in the shaded area is a solution to the system. One more example. Same directions, graph 3x plus a half y is less than 2. So I'm going to solve that for y. I'm going to subtract 3x from both sides. So that gives me 1/2 y is less than negative 3x plus 2. And remember, instead of saying dividing by half, I prefer to think of it as multiplying by 2. So multiply both sides by 2. That cancels that out, giving you y is less than negative 6x plus 4. I'm distributing the 2 into the negative 3x, the 2 into the other 2. So then I graph that. So I start at 4, place a point at 4, and then from there I'm going to go down 6. My slope is negative 6, that's negative 6 over 1. So down 6, 1, 2, 3, 4, 5, 6, till to the right 1. Now, which type of boundary line should I use on this one? So since it uses just a less than symbol and it's not equal to, I'm going to use a dotted boundary line, just like we did on the previous one. But if you come across some that are equal to, you're going to have to use solid. Using a straight edge is beneficial too, but as we've already figured out, this program doesn't let me do a dotted straight line. And then I got to figure out which side of the line to shade. So I noticed that 0, 0 is not on the boundary line. And if the 0, 0 is on the boundary line, you have to pick something else. So is 3 times 0 plus a half times 0, is that less than 2? Well, that gives me 0 plus 0, and is that less than 2? Yes, it is. So this time, since that is less, it gives me a true sentence, I'm going to shade the side that contains the 0, 0 test point, which in this case is the left side. So I'm going to wind up shading that entire side. So I shade the entire left side there. So every point that's in that area, it makes that a true sentence.